Hi. In this video lecture, we're going to look into the built-in library functions provided by C to perform searching. Whenever we talk about searching, we have two types of searching. One is the linear search, the other one is the binary search. Quite often, we basically try to write our own code for linear search and as well as even for the binary search. But today, we are going to learn the library function provided by the C language. For linear search, the C library provides two functions. One is called as the lfind and the other one is the lsearch. There's a small difference between lfind and lsearch, but in today's session, we're going to study about lfind. So let's look into the lfind. The lfind function basically takes 5 arguments. The first argument is basically the key, and you can observe that we need to pass the address of the key, right? So which is of type void star, a void pointer, and the key argument will not be modified. That's the reason why we have pointed to const. The second argument is the base address of an array which holds the elements. And third argument is the number of elements. And you can also observe that, that is also a pointer, meaning we need to pass the address of the variable which holds the number of elements. And the fourth argument is the size of each element, which is of type size underscore t. And then the last argument is a comparison function where we need to specify how do we compare two elements. Now, the comparison function is a user-defined function where you write the code how to compare two elements depending upon the data type. Like if it is basically integers, we're going to do with the help of relational operators. If it is string, we basically use string compare. Fine. And that returns me a void pointer. It returns me a void pointer. Fine. So let's start implementing this particular code. Now, here I do have a compiler, like online compiler called as Python tutor, wherein first I'll try to include the required header files, stdio.h for the printf statements. And then if you want to use this lfind and lsearch, we need to include the header file search.h. So we'll just try to include this search.h. Right? Then let's try to have an array of elements. You can just create an array and you can have any elements. And since it's a linear search, there is no condition that the element should be in arranged order. It can be an arranged order. Even if it is not in arranged order, it's perfectly okay. So after that, we'd like to calculate the number of elements and observe this. The number of elements, the type should be size underscore t. So I'll just try to mention this as size underscore t. N. I'm trying to calculate the size of the array by writing the expression size of array, which is the total amount of memory allocated for the entire array divided by size of each element. Each element is an integer, so size of integer. That gives me the value of n. So after that, I'd like to have a key element. You can take up any key element. You can take up first, let's try to take up an element which is existing. Then we'll try to see the element which is non-existing. The type of key will be the same as type of an array. Now, let's try to use lfind. The first one, we need to pass the address of key. Second one, we need to pass the base address of an array. Just mentioning the name is sufficient. It's going to give me the base address of an array. The third one, we need to pass the address of n. The fourth one, we need to pass the size of each element. We need to specify size of each element. Here, size of each element is size of int. We can also hard code it as 4, but this is more portable. Now, the last one, we need to write a compare function, which should follow this particular interface. It should take 2 arguments of const void star, and it should return an integer. So let's try to write a comparison function out here. Return type should be integer. I'll say compare const void star, and we'll try to just look into what exactly the first parameter specifies and what exactly the second parameter specifies in this, and what should be the code inside this. So let's try to read this. It says the comparison function referenced by the compare is expected to have 2 arguments which point to the key object and to the array element. So the first parameter will be the key argument. Second one will be the array member which we need to compare, and which returns 0 if key object matches the array element. Remember, if it matches, it should return 0. It should return non-zero otherwise. So the first one is key, second one is the element which you want to compare, pointer to element what you want to compare, right? Here, they are void pointers, so I cannot dereference and directly compare it. So I need to typecast it. Since they are integer elements, I'll just be using typecasting, and then I'll try to dereference. And if that is equivalent to this, the element, whatever you're trying to compare, like first time, the element will be the first element of the array, second time it will be the second element of the array. So if that is equal, I need to return 0, otherwise I need to return 1. So this is something what I need to return. So my comparison function is done. Now, what does this lfind function return? It basically returns a pointer. You can just see it returns a pointer. And yes, if you're working with an integers, then we need to collect it back into an integer pointer. Now, what will be the value of this pointer if you find an element and if the element is not present? Let's see here. lfind returns a pointer to a matching member of the array or null if no match is found. So it returns null if the element is not present, and it returns a non-null value when the element is present. And what does the non-null value represent? It refers to the place where exactly the key element is present. So in case, let us say if you are searching for 56, so it returns me the address of this fourth element in this array. So let's try to complete this task. If ptr is not equal to null, it means that element is found. We'll just say printf element found. And if you want to know the index, remember whenever you do this pointer subtraction, it also gives me the ptr difference underscore t, which is of type generally long integers. I'm just using ld out there. And here the ptr minus the base address. And in case if the element is present, then we did this. But if the element is not present, I'd like to just say element not found. Right. So this is a code for searching. So let's try to run this program and we try to visualize this and understand how things are working. So I'm just trying to start execution of this. Okay, there are no errors. So first statement, we are going to create an array. And you can just observe that the array is created. The array is created with all the elements 12, 23, 21, and all those things. The next n value is calculated, n value is 6, and the next statement key is 56. Now I'm going to call this lfind by passing all the required arguments, and very important is I'm also passing this compare function, right? So I'd like to also see the addresses out here. I'll just try to look into the addresses. So here you can just observe these are the addresses of this element BC0, BC4 and everything. And this is the address of the key. Now I'd like to observe that here that I don't have a loop, but inside this lfind there is a loop, what we generally write when we try to write our own user-defined search function. Similar to that, there is a loop out here. So let's try to observe this. So here you can just observe the key in the compare function refers to this, right? And then so it will be first time it will basically refer to this BC0, and then it will go into this function compare. It will go to the compare function. It's going to compare that, and then if it is matches, it returns 0, otherwise non-zero. So you can just observe first time it did not match, and then you can always look with the addresses also. Second time you can just see the key is referring to BAC, which is the address of the key out here, and the element now is referring to BC4. Now it's referring to BC4. Yeah, previously it was referring to BC0. Previously it was referring to BC0. Now it's going to refer to BC4. We are comparing that, not match. Now, okay, the key remains the same. Element refers to the next element, BC8. Then you can just observe it refers to BCC. And then here, the element is matched. So it returns this BCC. It returns this BCC. You can just observe it returns this BCC. And once you get this, we can just do a simple pointer subtraction. And when you get this, okay, print the statement, you get the index. Right. Now, if you want to really observe that without this visualization tool, if you want to just know which two elements are compared, you can always write a statement here like this. Two elements are compared. And what is this? The first one is the key, second one is the element. This is a nice way to debug. The best way to debug is using the print statements. I've just done this. So here, I've already done it for 56. Let me just do it for 21, where 21 is also present in the list. And if you don't want to perform step-by-step execution, you can execute everything at one shot by just clicking on the last. So you can just see all the steps are executed. And you can just see first time it is 21, 12, 21, 23, 21, 21. If you want to print the addresses, you can also print the addresses. Instead of D, you can just use P and then print the addresses. Now, if you want, you can also search for the element which is not present. Like for example, I would like to search for 2, and a 2 is not present in the list. So if 2 is not present in the list, it's going to repeat the loop for n number of time, where n is 6 here. And after that, it says that, okay, the element is not present by returning null, returns null. You can just observe. So first, second, third, you can just keep observing. It's just doing. And finally, what happens is once you're done, okay, it returns null. It has returned me null out here. If it returns null, we basically say that element is not present. So here you can just also observe that it did compare with every element here. And once we are exhausted with comparing all the elements, then it basically says element not found. Okay. So I hope the concept is clear. The code will be present in the description section. Thank you.